Today's lesson is going to be on solving nonlinear systems. So far what we've worked with is a system of linear equations. We've tried to find where we will have a point of intersection between two straight lines. So we may have one point of intersection. We may have no intersecting lines because they're parallel, or we may have infinite solutions because they are the exact same line. When you're working with nonlinear systems, there may be more than one point of intersection. Most common that we'll see is going to be a system of equations, one being a parabola or quadratic equation and one being a line or a linear equation. There's still a possibility that they will not ever connect, so you could still have no solution. It could cross in exactly one location, so the line is tangent to the parabola, or it could go through two distinct locations where it would have 2 points of intersection. In order to solve a system of linear equations, we had a lot of options. We could use graphing, which is still an option for us. We could use substitution. We could use elimination, and we could use matrices with Cramer's rule to find the solution. Elimination and matrices will only work with linear equations. Since we have a quadratic equation here, we have to use either graphing or substitution. Mathematically, the easiest thing is substitution, where graphing you may get a good accurate graph. However, you might not be able to tell exactly what the solution is, especially if it's a decimal or a fraction. So we're going to use substitution. I know that y is equal to x squared minus 5x plus 7, and y is also equal to 2x plus 1. So I'm going to take what y is equal to from the top equation and substitute it into the bottom equation. So now I have x squared minus 5x plus 7 is equal to 2x plus 1. With it being a quadratic equation, that means I want to have everything on one side and I have my equation equal to 0. So I will subtract the 2x from both sides and subtract 1 from both sides to get x squared minus 7x plus 6 equals 0. Now that it is a quadratic equation set equal to 0, I can factor this, or I can use the quadratic formula to solve for x. I'm going to choose to factor because I realize very quickly that negative 6 times negative 1 is going to give me positive 6, and when I add those two numbers together it gives me negative 7. So that means x is equal to 6 and x is equal to 1. These are two solutions. This is only half of the solution. This is the x coordinate. So to find the y coordinate, I have to plug it back in. The easiest place to plug it back in is to the linear equation. So I'll have y is equal to 2 times 6 plus 1, which would give me 13. And y is equal to 2 times 1 plus 1, which would give me 3. So the two places where these equations will, or these graphs will connect, will be the point 6, 13 and the point 1, 3. So this solution has, or this system has two solutions. And from the graph, you can tell that we have two solutions. One of them is at the point 1, 3, and one of them is at the point 6, 13. The next system is y minus x squared equals 7 minus 5x, and 4y minus 8x equals negative 21. In order to use substitution, we need to have one of the equations solved for one of the variables. The easiest thing to do is move the x squared to the other side in this equation. So I'll have y equals positive x squared minus 5x plus 7. You could leave it as 7 minus 5x, that won't make any difference. Then I'm going to plug what y is equal to in for y in the other equation. So now I have 4 times x squared minus 5x plus 7 minus 8x equals negative 21. I will distribute my 4 to get 4x squared minus 20x plus 28 minus 8x equals negative 21. Because it is a squared or quadratic equation, I need to make sure that it is equal to 0 before I can solve. So combining my like terms and adding 21 to both sides, I have 4x squared minus 28x plus 49 equals 0. Now, I cannot divide all of the terms by a common denominator, by a greatest common factor. So I'm going to try to come up with something that will work. I'm going to use a guess and check method. Of course, you can always use a factor diamond or some other form of organizational method, but I recognize that 4 is a perfect square and 49 is a perfect square. So I'm going to try 2x and 7, 2x and 7, both of them being negative. 2x times negative 7 is negative 14x. Negative 7 times 2x is negative 14x. And when I combine those, I get negative 28x, which is what I was looking for in the middle. So that means my x value is going to be positive 7 over 2. And since they're exactly the same, it means that x is 7 over 2 twice. It's a double root, which means that it's going to touch or be tangent to this graph. So that's the x value. I also need to find the y value. So I'm going to go back up here to what y equals 7 over 2 squared minus 5 times 7 over 2 plus 7. And I'm going to let my calculator do the work for me. And it gives me 1.75. So that means that my point of intersection would be 3.5, which is my 7 over 2, and 1.75. Looking at the graph, it's counting by 2's, so that's 2, 3.5, 1.75, because that would be 2 right here. So it looks like that is accurate, 3.5, 1.75. Practical application, well, we don't really shoot cannons anymore, but this is kind of how we can come up with a practical application. A cannonball flies through the air following this parabola. Okay, so this is the path that it is taking. The land would slope upward at this rate, so 1/1500ths of an inch or a foot, whatever it may be measured in. Where does the cannonball land? So what we want to know is, when do these two intersect? So this is a place where you could solve a system of equations, and it's actually going to mean something. When is the cannonball going to be intersecting with the land? Whenever you solve this system, you find that your x value is 25 and your y value is 3.75. So if this were in feet, then it would be the x value would be probably 25 seconds, and your y value would be 3.75 feet.